Have you ever gazed up at the night sky and wondered, where did all this come from? Our solar system, with its brilliant sun, majestic planets, and countless smaller objects, is a marvel of cosmic order. But how did this intricate system arise from the chaos of space? The answer lies in a fascinating story of cosmic evolution that began billions of years ago. It all started with a giant, swirling cloud of gas and dust called the solar nebula. Imagine a vast, dark expanse of space sprinkled with the remnants of long-dead stars. This material, the very building blocks of our solar system, would eventually coalesce into the sun, planets, and everything in between. Join me on a journey through time as we explore the incredible story of the solar system's formation. The solar nebula, like many others scattered throughout the universe, was a chaotic and dynamic environment. It consisted mostly of hydrogen and helium, the lightest and most abundant elements in the cosmos. These gases were mixed with tiny dust grains, remnants of previous generations of stars that had long since exploded. These stellar ashes contained heavier elements like carbon, oxygen, and iron, essential ingredients for building planets and even life itself. Within this swirling cloud, gravity was constantly at work. Gravity is the force that attracts objects with mass towards each other. Tiny particles of dust, drawn together by this invisible force, began to clump together. These clumps, over vast stretches of time, grew larger and larger, forming denser regions within the nebula. This process, known as gravitational collapse, is the engine that drives the formation of stars and planetary systems. As the solar nebula continued to collapse under its own gravity, one central region became significantly denser than its surroundings. This dense core, constantly accumulating more and more material, began to spin faster and faster, like a spinning figure skater pulling their arms in. This rapid rotation also caused the core to heat up tremendously. The temperature at the core soared to millions of degrees, hot enough to initiate nuclear fusion. Nuclear fusion is the process where hydrogen atoms combine to form helium, releasing enormous amounts of energy in the process. This energy, in the form of light and heat, radiated outward from the core, creating a brilliant object at the center of the collapsing nebula, a protostar, the precursor to our very own sun. The protostar's intense radiation began to push away nearby gas and dust, shaping the surrounding material into a flattened disk. With the protostar blazing at its center, the remaining gas and dust in the solar nebula settled into a swirling disk. This disk, called the protoplanetary disk, is where the magic of planet formation would take place. Imagine a giant cosmic pizza crust surrounding the young glowing protostar. This disk, far from being uniform, was a dynamic environment, teeming with activity. Within the disk, the same forces that governed the nebula's collapse continued to operate. Gravity drew particles together, causing them to collide and stick. Closer to the protostar, where temperatures were scorching, only rocky materials like iron and silicate minerals could withstand the heat. Further out, beyond what we call the frost line, temperatures were cold enough for ices made of water, methane, and ammonia to solidify. This difference in composition would play a crucial role in the types of planets that formed. Section 5, accretion from dust grains to planetesimals. In the protoplanetary disk, the process of accretion was in full swing. Tiny dust grains, constantly in motion, collided with each other. Some collisions were destructive, shattering particles into smaller pieces, but many resulted in gentle mergers, with particles sticking together through electrostatic forces. Over time, these tiny aggregates grew larger, forming pebble-sized objects, then boulder-sized, and eventually kilometer-sized bodies called planetesimals. Imagine a snowball rolling down a hill, gathering more snow as it goes, growing larger and larger. That's similar to how planetesimals grew in the early solar system. As these planetesimals zipped around the protostar, their gravitational pull increased. They began to attract smaller objects and other planetesimals, pulling them into their growing gravitational influence. These collisions, sometimes gentle, sometimes catastrophic, shaped the destiny of these early planetary building blocks. Section 6, terrestrial titans and gas giants, a tale of two planet types. Within the protoplanetary disk, two distinct types of planets began to emerge. terrestrial planets and gas giants. Closer to the Sun, rocky planetesimals reign supreme, forming Mercury, Venus, Earth, and Mars. Beyond the frost line, icy planetesimals formed the gas giants, Jupiter, Saturn, Uranus, and Neptune. Their massive gravity captured vast amounts of hydrogen and helium, forming thick atmospheres. Section 7, the solar wind, a cosmic broom. As the young sun entered its stellar phase, it unleashed the solar wind, a stream of charged particles from the sun's upper atmosphere. This wind swept through the solar system, clearing gas and dust. Acting like a cosmic broom, it revealed newly formed planets. This process took millions of years. Gas giants retained their massive atmospheres. Terrestrial planets lost lighter elements, leaving rocky worlds. Section 8. Lunar companions, the formation of moons. While the planets were taking shape, so too were their lunar companions. Moons, the natural satellites that orbit planets, formed through a variety of processes. Some moons are believed to be captured objects, such as asteroids or comets, that strayed too close to a planet's gravitational pull. Others likely formed from the leftover material in the protoplanetary disk, coalescing into smaller bodies that became gravitationally bound to their larger planetary neighbors. Our own moon, for example, is thought to have formed from a cataclysmic impact early in Earth's history. A Mars-sized object is believed to have slammed into the young Earth, ejecting a massive amount of material into space. This material eventually coalesced under its own gravity, forming the moon we see in the night sky. Section 9. A stable system emerges, our cosmic home. After millions of years of chaotic collisions, a stable solar system emerged. The planets settled into their current orbits around the Sun. The Sun provided the light and heat necessary for life to evolve. This balance between gravity and energy is a testament to cosmic evolution. Our solar system is in constant motion. The planets continue their dance around the Sun. Asteroids and comets still hurtle through space, leaving their mark. Section 10. Beyond our Sun, planetary systems throughout the cosmos. For centuries, our solar system was the only planetary system we knew of. But in recent decades, astronomers have discovered thousands of planetary systems orbiting other stars in our galaxy. These exoplanetary systems, as they are called, display an incredible diversity in size, composition, and orbital arrangements. Some systems harbor gas giants orbiting incredibly close to their host stars, while others contain rocky planets in tightly packed configurations. This newfound knowledge has revolutionized our understanding of planet formation. It's clear that the processes that gave rise to our solar system are not unique. Planet formation is a fundamental process that occurs throughout the universe, driven by the same laws of physics that govern our own cosmic neighborhood. Section 11. Conclusion: a universe of possibilities. The formation of our solar system is a testament to the incredible power of gravity, time, and chance. From a vast cloud of gas and dust, a star and its planetary companions emerged, creating a cosmic oasis capable of supporting life. As we continue to explore the universe, we are finding that planetary systems are not the exception, but the rule. The ingredients for planet formation are everywhere, scattered throughout the cosmos. In the swirling disks of gas and dust that surround young stars, new worlds are constantly being born. The story of our solar system is just one chapter in the grand narrative of cosmic evolution, a story that continues to unfold with each new discovery. Subscribe to the channel, like the video, and comment down below what fascinates you the most about our solar system.